and good morning to everyone. I hope you guys in a good condition. Alright, so today we are going to start a new and exciting topic in mathematics, which is function. Functions are a fundamental concept that will help us understand various mathematical relationships and real-world phenomena. So, let's dive into the world of function and see how they can make complex relationships easier to understand. Alright, so for the very first subtopic, we will learn about functions. So in this, we will be able to know what is function. We also can state the domain and range of function, and not just that, you also be able to find the composite functions. Okay, so students, what is function? A function is a special type of relation where each and every element in the domain has only one image in the range. For example, where we can relate to the real life situation is you are ordering a coffee for RM5 ringgit, and then you pay 5 ringgit, you will get one coffee, right? So if you pay 10 ringgit, you will get 2 coffees and so on. So the input, where is the domain, can be affected into the range, or the other words we call as the output. So this what we call as a function. Basically, functions are often written as f in bracket x or g in bracket x, where x is the input and f of x is the output. In function, we have two types of relations, whereas the first one is one-to-one relation and the second one is many-to-one relation. Both of these relations have domain and range. So, domain is all the possible x values on the graph, meanwhile range is all the possible value in y value on the graph. Next, for more explanation, I will show you the use in GeoGebra for how to find domain and range of function. So, I will show you how to find domain and range of function in GeoGebra. Okay, so given here is the function of gx equal to x squared minus 3x plus 7. As you can see here. Alright, so in order to find the domain and range, but first I would like to recall back what the domain and range is. So the domain is the set of all possible input values, which is the x values on the graph, x values here, x-intercept. So the range is the set of all possible output values, which is the y values. Okay, on the graph, the domain is the horizontal span and the range is the vertical span. Okay, so in order to find it, to find domain and range, you must know, need to look how far the graph left and right it goes, and for the range, how low and high the graph goes. Okay, so can you guess what is the domain and range for the function gx? Okay, as I said, the domain is the x values. So here we can see that x is more than 2 and less than 7. So the range will be, here we can see the high graph is 6, y is 6, and then the 3 is, the low is 3. So we can see here, alright, the low is 2. So the range will be y is more than 2 or equal to 2, but less than 6 or equal to 6. Okay, so if we move the graph, we change the function where it become the x square minus 6x plus 15. So the range will still the same, because we can see the low graph is still touch 2 and the higher graph is still touch the 6. But we can see here, if we change the graph, the function become x square minus 7x and plus 16, the range will increase because of the height of graph is increases. So the range will be more than 2 or equal to 2, but less than 8 or equal to 8. Alright? Okay, so next we will look at the composite function. Okay, so composite function is basically a complex function created by two or more functions. As you can see from the diagram in the slide, the function of g of x and function of f of x will become a new function h of x. So we will look at the GeoGebra in order how to find the composite function. So for the composite function, we will have two or more functions. Okay, given here, the first function is x squared minus 4x plus 8, and the second function is gx equal to 8x plus 5. So you can see we will have the two functions in the graph, on the graph. Okay, so here given that the question asks to find the composite function of f and gx. So usually what we gonna do is, you can see in here gx will become the first function actually. So in order to solve it, you have to let the gx here in the function of fx, meaning that you have to substitute the gx in the x of the function fx. So it will become like this: x plus 5 squared minus 4 gx in here, x plus 5 plus 8. So the answer will become x squared plus 6x plus 13. Okay, so next question, you have to find the function of g composed with the function of fx. So what you have to do, just same like this, you have to substitute the function of fx in the gx. So it will become like this: x squared minus 4x plus 8 in the x of the gx, and then you will plus 5, and the answer will become the x squared minus 4x plus 13. Alright, so in case if I change the function of fx, where x plus 5 plus 4, and the gx, I want to put x minus 16. Alright, okay. So you have to find the compose of function of fx and gx. So what you're gonna do first is, you have to substitute the function of gx here in the x of function fx. So you become x squared minus 16 in the x of function fx plus 4. So the answer will become x squared minus 12. Alright. Next question is you have to find the composite function of gx and also fx. So what you have to do, just repeat the same step. Have to find, you have to substitute the fx, function fx here in the x of gx. So it will become x plus 4 squared minus 16, and the answer will become x in bracket x plus 5. So I hope you will understand this composite function.
Hi everyone, I'm Nur Atira binti Rizwan. So today I will present to you about one-to-one function. So, have you ever heard about one-to-one function? One-to-one function is the map's distinct element of its domain to distinct element of its codomain. So, as you can see here, this topic has the specific 6 concepts. We will start with the first concept, which is to determine whether or not a function is one-to-one function that we can use by using the horizontal line test. For the second is if there is only one intersection point, the function is also one-to-one function. For the third is if it's one-to-one function, the domain of f inverse is the range of f, and the range of f inverse is the domain of f. So for the fourth concept is the graph. The graph of f and f inverse are symmetrical about the straight line, which is y equal to x. And for the fifth, the inverse function only exists for one-to-one function. As you can see, one-to-one function that related with domain and codomain. So for the last concept is a function which is not one-to-one that can have an inverse function if we restrict the domain of the function so that one-to-one can be used when we are restrict the function by using the completing the square. As you can see here, I have shown you the one-to-one function in the GeoGebra. So, if you explore more detail about the GeoGebra, you can use everything, not about the function. Also, you can use for one-to-one, many-to-one, and you can see how the intersection touch or intersect with the horizontal line test. So, in this GeoGebra, I'm used the first concept of one-to-one, which is to determine whether or not a function is one-to-one function that we can use the horizontal line test. As you can see here, I have attached the way how you need to use the horizontal line test. So, in this GeoGebra also, I have attached 4 examples of linear equation. For one-to-one, at first, the example as I showed to you, the linear equation which is negative 2x minus 10 with the straight line. This graph that proves the only one intersection that can touch with the horizontal line test. As I mentioned before, in this concept, if you only one touch with the horizontal line test and also your linear, you can get your one-to-one function. But if your linear function will touch with 2 or 3 or any more with the horizontal line test, which is show you that you have not one-to-one the result for the function. So there show the horizontal line test will move up and will move down, that to prove the intersection point for each function. As you can see, for clearly, I have put the checkbox over the GeoGebra. If you want to see the graph clearly, you can turn on the horizontal button line test. But if you want to see the only intersection, you can turn on the checkbox. So you will get the accurate value of each intersection when you have clicked the checkbox that show clearly on the GeoGebra. Graphical test for one-to-one by draw a horizontal line that intersection the graph of the function at most one. It can prove it as one-to-one function. Then we also can use the algebraic test to compare the output and different input. So input and output such as domain and codomain, you can see that the result of domain and codomain is the final one-to-one or not one-to-one. For this session, I will show you the example of function not one-to-one in algebraic calculation and also in graphical test in GeoGebra. As I have mentioned before, in the since concept that the equation need to restrict to form one-to-one function, that we need to use the completing the square. Here, what's the example of the completing the square? That the function that I apply is the square root square plus 2x plus 5. Then you need to recognize the which algebraic A, B, and C. This is because when you know and recognize which A, B, and C, you need to form this algebraic in the formula. So the detail of the formula, you need to fill up the formula to see the different domain and codomain function to get the result, which is this graph is the one-to-one function or this graph is not one-to-one function. You can see when the intersection graph with the horizontal line test. So I can summarize that a one-to-one function is also known as the injective function, that is a type of the function in mathematics that where each of the function in mathematics have the element of the domain where mapped to the unique element which is the codomain. This means that no two different of element in the domain can map to the same element in the codomain, such as each input has a distance of the output. So one-to-one function have passed the horizontal line test, which means that a horizontal line test intersect the graph of the function at most one. So this property that can ensure the function can be inverted, where each the output value unique corresponding to one input value. So in this GeoGebra, you can see that each intersection only once happen when the function have one-to-one. But if for example, in the quadratic example, you can see the two of the intersection will be occur. So that's all from me. Thank you.
Hello everyone, I'm Nur Amalia Aisyah and I will be teaching about the graph of functions. Understanding the graph of a function is crucial because it gives us a visual representation on how the function behaves. We will cover key concepts, examples, and how to use GeoGebra to enhance our learning. There are 4 types of functions. So let's start by plotting some basic functions. One of the simplest function is the linear function, which is fx equals to ax plus b, or more known as mx plus c, where m is the slope and c is the y-intercept. This function represents a straight line. So now I will show you on how to use GeoGebra when solving the linear function. In my GeoGebra that I've done here, it has A, B, C, and D, where A is for x cubed, B is for x squared, and C is for x. D is for constant. So linear is mx plus c. So it only have x here and plus constant. So I give you example, which is 2x minus 4. So we put here 2, the c, move it to 2. So you can see here 2x, and the d is minus 4. Minus 4. So it will move here, the constant is minus 4. So the equation is fx equals to 2x minus 4. So the type of function shows here is linear function. So that is how we use GeoGebra when solving the linear function. Next, let's have a look at the quadratic function. Quadratic functions are polynomial functions of degree 2, and they have the general form of ax squared plus bx plus c, where a, b, and c are constants and a not equal to 0. The graph of quadratic function is a parabola which can open upwards or downwards depending on the sign of a.
So quadratic function has a degree of 2. So as you can see earlier, for the linear function, I only move the c1 because it is for the x. So for the degree, the x squared, we will be moving this b here. So I will give you an example, which is 3x squared. So we move this one, 3x squared. So plus 1. So and the constant I will put it minus 6. So as you can see here, quadratic function, it will curve like this. But if I put b to 0, it will automatically turn to linear function.
Now, let's explore cubic functions, which are polynomials of degree 3. The general form of a cubic function is ax cubed plus bx squared plus cx plus d. Cubic functions can have various shapes, including up to 3 roots and 2 turning points.
Next is about cubic function, which is cubic function is the degree of 3. So here we will use all of this slide to create the cubic function. So the previous one is quadratic function. So as we move this a slide, it will turn into cubic function. As you can see here, it has turned into cubic function. If the b is 0, it is still a cubic function because a exists.
Lastly, let's have a look at reciprocal functions, which are the form of k per x, where k is a constant. Reciprocal functions have hyperbolic shapes and are characterized by vertical and horizontal asymptotes. For example, consider the function 1 over x. This function has a vertical asymptotes at x equal to 0 and a horizontal asymptotes at y equal to 0.
And lastly, this is the reciprocal function,
where in the textbook the equation is 1 over ax minus b. So if we move the a slider, it will show you that the graph will not touch each other no matter how increase the number of a is, and it will also not touch the y-axis here. So as for slide B, it only moves to x-axis. Here are some examples and we will be using GeoGebra to solve it. As for the first question, it asks you to find the 2x minus 1 and the type of graph. A is for the x cube, B is for the x square. So we only move the C and D. Move here 2x and minus 1. So minus 1, the D, we will move minus 1 here. So as you can see here, it shows like the question 2x minus 1. The type of function is linear function. So this is the graph. Okay, so the next question asks for x squared minus 4x. So x squared is a quadratic function. So we move the slider B here to 1. And the x is minus 4 and D is 0. Yes, so as we look here, x squared minus 4x here. And the type of function is quadratic function. It is a smile graph here. Now, the next question asks for 6x cubed. So 6x cubed, we will move the A slide to 6, 3, 4, 5, 6. And plus 2x, which is 2x, and plus 3, D is 3. So the equation will show you like this. It is the same as the question given, and the type of function is cubic function. How does the graph look like? Here it is. This is the graph, the cubic function. And lastly, the D asks for 3 minus 2x minus 5x squared. So the constant is 3 and it has 2x. 2x is C minus 2 and there is a square, x squared minus x squared, 5. 1, 2, 3, 4, 5. Okay, so the equation will look like this. It's a quadratic function. And how does the graph look like? It will look set like this. So as for this question, before we use the GeoGebra website, we can calculate it manually, where as we know that the A is negative 1, which is less than 0, so the graph will be upside down. So when we want to search for their intersect, we can put y equal to 0 and x equal to 0. So when y is equal to 0, we can solve it using the equation given in the question. So when y is equal to 0, if we calculate it manually, so we will get x is negative 1 or 2. So we will have two intersection when y is equal to 0. So when x is equal to 0, y is 2. So there are three intersections when this equation intersect with x-axis and y-axis. We insert the equation first, which is the constant is 2, and we plus x. For b, we plus x, 1, and the square, x square is minus 1, like this. Okay, so the type of function is quadratic function, and the equation looks like this, and the graph is a set graph because the a is less than 0. So how do we look for their intersection is, as you can see here, we can find it by using GeoGebra easily, which is the first intersection is 0, 2, when x 0 and y is 2, and the second one is y 0, the x is -1, and y 0, the x is 2. So here is the ways to use GeoGebra in finding graph of function.
Hi, I am Miss Najwa. You have been learned how to find domain, range, composite function, and how to determine function as one-to-one function by find the inverse function, and how to sketch the graph by using the function given. In this section, it more focused to get a correct answer for STPM question. I have been ready with 2 STPM question about linear function and another one about quadratic function for this subtopic. So, let's begin. So, first we need to identify what type of the function. We will know the function as a linear function because the x in this function do not have the power. So, it is a linear function. Let's read the question first. The function f is defined by fx equal to 2x minus 5. X any real number. A. State the domain and range of the f. B. Find the inverse of the fx. C. Sketch the graph of the f and the inverse f. So, let's get a correct answer for this clone question STPM. For the first question, we know that it was 2x minus 5. So, we set it as 2x minus 5. And for the first question was A, which is find domain and range. You should know domain for linear, quadratic, and also polynomial. It always any real number for domain. So we know that the domain for this equation is any real number. Next, for the range. For linear, any type of function, it will be always any real number. Same with the domain. Next was the inverse for inverse of question. We know that inverse of question find like we equal to x. So let's find is it using this was same with what we find in the paper. So 2x minus 5 equal to y. 2x 5 minus plus 5 x equal to y plus 5 divided by 2. So we change the y with x. F inverse f inverse equal to x plus 5 equal to 2. So we put 1 over 2 outside the equation, so we get 1 over 2 plus 5x plus 5. So same goes with our worksheet. We get 1 over 2 in 1 over 2 f plus 5. For the graph, we alert that the graph was crossing 5 in this fx exit x, and the graph for the f will cross -5 at exits y. So that is for the first question. Another clone question about this subtopic, quadratic function. The function f is defined by fx equal to x squared plus 2x minus 4. A. State the domain and range of the f. B. Find the inverse of fx. C. Sketch the graph of fx and inverse f. Next, we will move on to quadratic function. As you can see, we will set it as the question given, which is x squared minus 2x plus 4. Okay, first we need to find domain and range. I will explain the domain first. For domain, as I said before, for linear, quadratic and also poly, it will be always any real number. So we will get it as any real number, x any real number. For range, it's different with linear. It will be have a value. For example, it will be more or less than the maximum or minimum point. So how we want to calculate the maximum or minimum point? I have one method. I will show you. Okay, first we know that the formula you need to remember was x equal to negative b over 2a. A for this equation was 1, b was 2. So we put in the formula x equal to negative 2 over 2 multiply with 1. So we get negative 2 over 2 and solve it as negative 1. So we put the value of x in the equation like this, f x, and put all the value of x as negative 1. Okay, negative 1 power of 2 plus 2 multiply with negative 1 plus minus negative 4. So we'll solve it. Negative 1, so we get it as negative 5. So our minimum point will be 5. So the range will be more than negative 5. What happened if our x square was negative? Okay, I will show you if it was negative. Our range will be different. That you can see as this graph. I will show you the graph negative and positive. I will change it. Okay, like this. Positive. It will be different maximum and minimum point. Okay, next let's move on for inverse function. Okay, for the inverse function, how to find it? Okay. And this worksheet will be the answer, but what if we write it in the paper? So I will show you. we will add y in the equation, which is equal to y, and put it together. X squared plus 2x minus 4 minus y equal to 0. So we put it in the equation, which is negative b plus minus square root b squared minus 4ac over 2a. We identify which is A, B and C. We know that our A was 1, our B was 2 and C is negative 4 plus y. Okay, we put in the formula. Negative 2 plus negative 2 over 2 will be 1, negative 1, and plus minus we will simulate it. We will be 2 square root 5 and 2 square root y. So we will put together the 2. So it will be, we will get negative 1 plus minus square root 5 plus y. Same as our worksheet, we get the answers. And for the graph, as the worksheet only detect the positive one, we can see our graph for inverse get at negative 1. And for the graph for function, original function, we will get it as a smiley graph because it's positive, and the minimum point was negative 5. I think